Advent of Code, Day 6, Guard Gallivant. The historians use their fancy device again, this time to whisk you all away to the North Pole prototype suit manufacturing lab ... in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. I would imagine so. You still have to be careful of the time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You start by making a map, your puzzle input of the situation. For example, okay. The map shows current position of the guard. Okay. Oh, to indicate the guard is currently facing up. Okay. Any obstructions, grates, desks, alchemical reactors, etc. are shown as hash. Okay. Lab guards in 1518 follow a very strict patrol protocol, which involves repeatedly following these steps. If there's something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. All right. Following the above protocol, the guard moves up several times until she reaches an obstacle, in this case, a pile of failed suit prototypes. Because there's now an obstacle in front of the guard, she turns right. Okay, I think I understand. And then we go down, and we go to the left, and so on. This process continues for a while, but the guard eventually leaves the mapped area. Okay, by predicting the guard's route, you can determine which specific positions in the lab which will be... Okay, all right, so we're just going to set this up, hit it with a hash set, and calculate the size. Seems pretty straightforward. We're going to do here, 18 down, delete that. We'll move day 5 up to here. Remove that from day 6. Put it here. Move day 6 down here. Eventually, things will all line up again. AOC 2024. Day 06. And then we have part 6 unsolved. Okay, so get input. 2024, 6. It's very big. 130 lines long, and it looks like it might be 130 lines wide. My window is 100, I think. So let me make it a little bit wider so I can fit the line numbers in there. Okay. So this is, I'm just going to do hash map like I normally do. So this is going to be, what is this called? This is called the lab. Hash map of, oh no, it's just, all we need is a hash set of I64, I64s. And that should give us all the obstacles. Oh, and then we'll need the guard starting location. Oh, can the guard be facing different directions? It just said there was a single guard. The map shows the current position of the guard with up arrow to indicate the guard is currently facing up. Let me take a look at the input. Is there a caret? There is. And there's no greater thans. Okay. Or less thans or V's. Okay. So interesting. So the guard is going to be at an I64, I64. That's the guard's start position. So we just work our way. Let data lines equals AOC lib, read lines of the input. And we're going to say for row line in lines iter enumerate for call ch in line chars enumerate. I'm assuming that the guard is not standing on an obstacle, right? I don't think it said that, but I think that's a reasonable assumption to make. We're going to say if ch is equal to this, and we're going to insert into our self lab row as I64, call as I64. else if ch equal, I should do a match, right? The caret then self guard equals row as I64, call as I64. Okay, so now we have the grid, and I think it's just very simple. Let visited is equal to hash set new. The guard starting position, let mut guard equals self guard. We're going to have directions for dir. Oh no, we're going to keep going until the guard's out of bounds, while guard 0 is less greater than or equal to 0, and guard, I should save rows calls, right? Rows I64, calls I64. And guard 0 is less than self rows, and guard 1 is greater than or equal to 0, and guard 1 is less than or equal to self calls. We're going to do this. I do need to save the rows and columns. Self rows equals lines len, and self calls is lines 0 len. All right, so while the guard is in bounds, we're going, so we need directions. Let's do this again. Const dirs is I64 semicolon 4. So it can only go up, down, left, right. And what I'll do is I'll do this in the rotation order. We're always going to turn right. So we're going to start by going up. And then turning right. Right is going to be this. And then we're going to turn right, which is going to make us go down, which is this. And we turn right again, which is going to be to the left, which is this. Can we fit that all in one line, or will it reformat? Nice. Okay. So let mut cur dir equals 0. While the guard is in place, we're going to say visited insert guard. Guard 0 plus equals dirs. Oh, no, we want to check. And we're going to say let new lock is equal to guard 0 plus dirs cur dir 0, comma, guard 1 plus dirs cur dir of 1. So now we have a new location, and we're going to check to see if we can visit that location. If we can't, then we're going to turn right instead. If self lab contains new lock, then turn right. And turning right is simply cur dir equals cur dir plus 1 mod dirs len. Oh, that's okay. That's okay. So we'll turn right. And we're just going to recheck the same location and reinsert the same location. That's why we have a hash map. And then we get the new location for having turned right. Yeah, it's a little inefficient, but I can live with that. And then all we need now is visited len, number of locations we visited. And we can't do this for some reason. Oh, cur dir. That was dumb. Cur dir. Okay, and now, we don't need to make that a thing. And we have an infinite loop. This can't be taking this long. Okay. So guard equals new lock. Else, I guess. Yeah, 4696. That's a reasonable number. Yay, that's the right answer. Okay, that was pretty straightforward. Git status, git add source, git commit -am 2024 day 6 part 1. All right, continue to part 2. While the historians begin working around the guard's patrol route, You borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Returning after what seems like only a few seconds to historians. Oh, to the historians only look like a few seconds, yep. They explain that the guard's patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. Oh, good. They're only pretty sure, though. They'd like to place the new obstruction in such a way that the guard will get stuck in the loop. Oh, okay. Yeah, so if we visit the same place twice, got it. Making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, historians would like to know all of the possible... Oh, for such an obstruction. The new obstruction can't be placed at the guard's starting position. Okay, that's fair. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations use O to mark the new obstruction, pipe to show a position where the guard moves up down, minus to show... Okay. No, I think I get it. So what we're going to do, we're going to do a little bit of a refactor. 2406. And we're going to actually put visited here. Because then we're going to check for each visited location, if we put an obstacle there, would we create a loop? And we have to count how many? How many different positions could you choose for this obstruction? Yeah. All right. This shouldn't be too bad. So instead of this, we're going to do this. Boom. Oh, just remove that line altogether. Self-visited, insert guard, blah, blah, blah. Okay. Now we are inserting the guard's 4696. Yes, that was right. Just double checking. Yep. Okay. We are going to have to skip that one, but we can say for position in self-visited iter, maybe. And this gives us a reference to the position that we want to put an obstruction on. And we need to detect to see if we have a loop. So it's basically this same kind of code. The only thing is, okay, if pause is equal to self guard. Continue. We want to skip this. We can't put the obstruction in the guard starting position. The difference here, though, is we want to keep track of not just the guard's position. Let loop detector equals hash set new. We want to see if the guard facing this particular direction has been visited before. If we're able to insert it, that means there's no loop. Self. We want to dereference pause. Okay. Here we're going to actually we're going to start the guard in the guard position, but the difference is we're going to now check to see if lab contains this or new lock is equal to pause or, right? This might take a while to run. I'm going to exit out of this again. I do need a semicolon there. Now we don't want to do self-visited insert. We want loop detector. If we found a loop, which means we inserted a new entry into the loop detector, it means we want to increment, right? Because we're counting how many loops there are. And we're going to just, oops, keep doing that. Total, there. Now, what is this not like? The binding total is a variable in different scope. Oh, no, I want yes. Thank you. Thank you, Russ, for catching that bug. All right. This might take a little while to run. I'm going to do release. Ouch. That is not fast. Do I have a bug? I guess I could print out. Maybe I have an infinite loop here. Oh yeah. Of course I do, because there's a loop. I got a break once I find the loop. Duh. There we go. 380. Let's see if 380 is right. Oh, my answer's too low. Okay. Yeah, as soon as we find the guard on in the same spot in the same direction, then we definitely have a loop. If we come out of this while, there is no loop, so total doesn't get incremented. Oh wait, do I have this backwards? If the set did not previously contain this value, true is returned. Right. Okay, that's good. That means we were able to insert it without overwriting something, and we keep going. We couldn't. Oh, yeah. Wouldn't I say, no, I don't want to do that? I could have sworn I said that I didn't want to do that, and then I... Okay, 1443. That's higher, so it matches the answer is too low. Hey, that's the right answer. Okay.